In this video, I'm going to share a new modular toolkit I've been developing for working with Gaussian Splats. Previously, I've worked with the Gaussian Splat Viewer plugin, which I've shown in various tutorials, and this is really great for working with singular splats. But for creative and geometrical edits, we have to go inside this component, and it's already reasonably complex, and when we start adding different operations, it can get complicated quite fast. What I have done in this modular toolset is I have taken all of the steps that were used in the previous plugin and I've packaged them as separate components. So we have our load component where we load our splat. We can then basically do any operation that we would on a regular point file, which means we can really easily use any of the pop operators to make significant changes. Once we've completed whatever our network's going to be in that area, we can bring that into a GSPOP calculation. And this is where we can do things like scale the splat size. And this basically is where we add in the shaders and the logic that makes this into a Gaussian splat. So, we could go and make this really big. This is where we go from points to splats. And this calculates all of the spherical harmonics and everything that we need to convert that into a splat for our render section. And then once that's done, we can hook that into a GSPOP render, which basically gives us access to the camera and things like auto rotate, translation in various axes, rotation, pivot, and scale. What I'm going to show you today is a simple pipeline using this modular toolset, as well as some experimentation with different TouchDesigner operators to make a weird and wonderful mirrored effect, sort of like this. I am making these components available on the Patreon for Patcher tier and above, so you will have to sign up to Patreon to access the toolset itself. Whilst the toolset makes this a lot easier, you can follow through and use a lot of the same logic in the Gaussian Splat Viewer, which is free. It will just be a little bit less intuitive to build. The first thing I want to do in my network is bring in the 3 core components. The load component allows us to load in a point file, and it doesn't do anything else, it just holds that point file. The calculation performs the calculations to take that Gaussian splat data and feed it through to the renderer to give it size and rotation. And then the renderer ties everything together. And now we can see that we are rendering down the chain. If I split my screen and add in a panel, we can see that that feeds through to the panel and we can interact with that. I'm going to change the point cloud because I don't want to see me. So let's go and do a different one. So I have selected the point file that I want to work with. I've set up that initial render network, and now I'm ready to make some operations to it. What makes this technique super powerful is that it's in stages. So literally this GSPOP load is just loading in that point file and allowing us to pass it through to these additional stages where we calculate and then render. And what this means is we can basically put any operation that we like in between this load and this calculator. I often start out with a delete. I set it to bounding. We can see there it's deleting the central section. So I'll hit that invert and switch it around. And now we have a bounding box. I'm going to scale that down a little bit because I just want to access the flower. And when you're working with something like this that might have a sort of spherical kind of nature, you can switch from bounding box to bounding sphere, and that can be a bit more forgiving on these types of structures. Oops. And if your computer runs reasonably slow when you work with Gaussian splats, it can be useful to add a second delete and go to the thin tab, turn on the enable and thin random and move that down a little bit so you retain the shape but you don't lose too much data. You can see here we're losing basically 50-60% of the data. It's not really legible, so let's go down here. but any little helps there. And with that thin random, you can smooth it out a little bit by working with your GSPOP calculation and moving that Gaussian splat up. That's way too much. But see, now I've moved that up, we have kind of reintroduced a bit more detail, although it is a little bit blurry. So you can also play with this alpha threshold just to get a value that you like. In the example I showed earlier, I was working with lots of copies. What I'm going to do here is I'm going to add a transform, and I'm also going to add in a copy. Let's copy this 4 times. Bear in mind, if you set this too high, this is a great way of really slowing down or crashing your project, so be sparing with this. And once I've instanced all those copies, we can see that it is now much brighter because basically these are all overlaid on each other. I want to play around with the rotate, so I'll kind of experiment and see what axis I like. And this is going to create a rotation per splat that we're copying. And what I really want to do is I want to basically rotate by a total of 360 degrees, split across the 4 copies. So each one will be rotated by a chunk of that. And we can make it modular as well. So if we change the number of copies, it will move with that as well. So on our rotate, we're going to write 360 divided by me.par.ncy. And NCY is the attribute for number of copies. So if I move that up, we can see that that is moving too. And we could copy that over there and see how that looks. And you can also go in and automate more of those to create sort of a ball. What I'm going to do is I'm going to turn down my splat size because now it's getting quite dense. I'm going to keep the alpha threshold at 0, and this second delete I will remove just so I get all of that detail, or as much as possible, sort of coming through. What I also want to do is I want to play with this transform. And we can see if we make small adjustments to that transform, we get a very different kind of shape. Because we're offsetting that central point. And also if we do things like different rotations and things like that, it's going to make a fairly big difference. So just playing around with these parameters can allow for some really nice effects to be kind of introduced into your work. Another way that we can use the copy is through this second input, and this allows us to take a template, and in this case I'm going to make a template of static points. I'm going to create 5, and that will be on the second tab, and they're all going to be set to 0, 0, 0, 0, which is going to create 5 copies of that shape. What I can then do is add in a pattern. In this case, it's going to offset the P, and I actually don't want to do that. I want to create a rotate parameter, and I also want to override attribute so we have 3 parameters available. In the copy, let's go and set this to rotate, and let's tweak these values. So we're going to have a sine, a cosine, and then whatever you want really, but let's go for a triangle. We're going to set the map from low to high to -1 for each of these, and then we'll set this to 360 for all of these as well. Okay, very cool. And now what we're going to do is we're also going to use this transform to bring everything closer together again. So it's all going to be in that little ball. And you can play with the transform to create some offsets here, but if you want just the sort of the basic static ball, then you kind of keep it as is. I'm going to do a bit of negative offset here, And really, you can see it's just sort of experimenting and playing around until you have something you like. In this case, I want to rotate some of these flowers so that they are facing outwards. So again, I'll just maneuver kind of by eye. I'm not the best at thinking in kind of 3D, so I kind of just do it until it feels right. Let's see if this does anything. Obviously, you could kind of automate these as well and have some animation there. But the next step is I actually want to animate these with the pattern. So if I automate the phase with some abstime.seconds, slow it down a little bit. And each one can have a slightly different divisor. So I've got abstime.seconds 0.02, 0.03, and 0.04. Again, maybe I've tweaked that a little too much, or maybe I've deleted a bit much. You can kind of play around with all these things. You can expand that out, and then you get a more dense cloud. Another thing I like to do is after the copy is, again, another delete, lots of deletes in this network, and again with the bounding box. And in this case, I really will use a bounding box. I'll invert that. And what this allows us to have is basically something that's not going to be too big externally beyond the actual copied geometry, because again, these things can get pretty big. You could play with the uniform scale and get something a bit more abstract. You can go in and add all sorts of things like you would normally, add a noise, basically do whatever kind of processes you normally enjoy working with in these types of environments. That's actually really nice. So I'm going to bring this up a bit. We'll tweak that noise down. Again, because we're working with copies, we could do things like change the scale. You could add in another pattern. And let's change that to scale. In the copy, we'll go to template again and just change that to scale. This could get a little hairy. I'm using a ramp, so I don't want it to be too big, and I also don't want it to be too small. So 0 to 1 to 0.1 to 1. Sometimes with these Gaussian splats, things get a little weird if the value goes below 0. Again, you could automate that with an abstime.seconds. And again, you could go in and do something else. The sign will be a little bit weird right now, so I'll just tweak that to -1 to 1. But I like that a lot better as an effect. So here we have a pretty cool little network where you can make some really interesting things. And obviously you can just apply anything you like in this network because it's just pops. You know, if you just want to add in a twist, you can do that. It's super easy. And you can then have it in your Gaussian Splat network. Ultimately, this makes it a lot easier for working with Gaussian Splats because basically we're just working with these 3 components, which we can then chain together with all of these operations that we would normally be using in between. Another thing we can do with this toolkit is it's really quite easy to load in multiple Gaussian splats. In this case, I have 2 loaded in, and then what I can do is I can move them around with various transforms. Zoom out that scene a little bit, which basically allow me to scale them into a scene, and then I could go in as well, like let's say for example I wanted to delete some of that initial scene of the plants on the ground, I could go in and do the old bounding box technique again. Copy that, bigger box. And then you have this method of sort of being really quite modular with your objects. If I just copy this, remove that transform, and now add a new splat. Let's do this one. We can see that loaded in there. Take off the transform, not lock the transform, just delete it. Add in a new transform because that obviously is a lot smaller than the other ones. Make that nice and big. We'll move it over there, up. Each of these has its own control as well for things like the splat size. So I can go in and change the splat size of these different items. And you can go really high if you want to. And it doesn't affect the other point clouds because basically you're feeding each one its own calculator and it's automatically going to readjust. It's a bit high. You can change their uniform scales. So essentially this is a fun way of also chaining different splats together and have it be very modular. This is not a particularly amazing scene that I've created here, so you can obviously do something a lot better. I hope this has given you some creative ideas for working with Gaussian splats, and I look forward to seeing what you do.